In the previous lecture, we seen how to downgrade HTTPS websites to HTTP, and this allowed us to basically see anything a user does on these websites because data in HTTP is sent in plain text. Therefore, we were able to see the usernames, the passwords, the URLs, and anything they do on HTTPS websites. At the end of the lecture, I also showed you that the method will not work against Facebook, Twitter, and other websites that use HSTS. The reason why it won't work against these websites because modern web browsers come with a list of websites that they should only load over HTTPS. See, what we were doing in the previous lecture, whenever a browser requests a website, we load that website even if it uses HTTPS, but we always give him back the HTTP version. In HSTS, the browser knows that this website, for example, facebook.com, should always be loaded over HTTPS. So even before sending this request to us, it'll always send it in HTTPS, and it'll always only accept it if it comes back as HTTPS. So there's nothing we can do really once we become the man in the middle, because the browser is doing this check locally. It's checking this against a list that is stored on the computer itself. Therefore, the only practical solution at the moment to bypass HSTS is to make the browser think that it is loading another website. To do this, we're going to replace all HSTS links in loaded pages to similar links, but they're not the same links. For example, we can replace facebook.com with facebook.corn. Now, I know this seems very suspicious, but trust me, when it goes into the URL bar, the RN here at the middle, it'll seem very similar to the M letter. Another way of doing this, you can replace twitter.com with twitter.com, but with a single T here instead of a double T. I know this sounds a little bit confusing right now, but let me go and do it practically and you will see how this is gonna work. So, right here I have my Kali machine, and we're actually going to use the HSTS caplet that we used in the previous lecture. So I've already showed you where to download it and where to place it. Please make sure you use the caplet that I gave you in the resources of this lecture, not the one that comes with better cap, because the one that I gave you in the resources of this lecture is modified and it contains code that will actually replace the domain names as shown in here. The original one does not contain that code, so it won't work as I'm going to show you right now. So, as shown in the previous lecture, I already have my caplet in here, in user share, better cap caplets, and this is the name of the caplet. If we go inside it, we have a file called hstshijack.cap. This is the configuration file of the caplet. So I'm going to right click it. I'm going to open it with other application. I'm going to click on view all applications, and you want to pick any text editor that you have. So I'm going to keep this at LeafPad. You might have to scroll down to find it, but I have it here. I'm going to select. And as you can see, we have a normal text file with all the configurations that we can set. And I've already pre-configured this for you. The main things that you want to understand and maybe change is the targets and the replacements. So the targets are the domains that use HSTS that you want to replace. For example, I have twitter.com in here, and I also have star.twitter.com. Basically, when you use a star, this is a wildcard, and it basically means any subdomain .twitter.com is a target as well. In the replacement, you want to tell the program what to replace this target with. For example, whenever we see twitter.com, we're going to replace it with twitter.corn. Similar goes for Facebook and Apple and a few other domains that I set. You can also play around with the obfuscate and encode options. I've set both of these to false because basically what these will do, they'll obfuscate the code and encode it. But I noticed some browsers like Firefox will block obfuscated or encoded code. That's why I set both of these to false so that the code is left as is. Here in the payloads, you can set any other JavaScript code that you want to inject. Leave this the same. We'll talk about JavaScript injection in a future lecture. Finally, you want to make sure that the DNS spoof domains are set exactly the same as the replacements in here. So I literally copy this line and paste it here. Now I'm actually going to keep all of this the same. I don't need to modify any of it. But like I said, if you're targeting different websites, or if you want to use different replacements, for example, if you wanted to use a Twitter with a single T and keep this .com, you can do that here. If you wanted to use a Facebook with a single O and keep this .com again instead of .corn, you can do it here. Once done, make sure you save and quit this file. And we're ready to run the attack. So running this attack is actually going to be identical to what we did in the previous lecture. You just want to make sure you modify this file properly. So going back to BetterCap, I'm going to clear the screen, run BetterCap with the same command, loading the spoof caplet so we can do all of the ARP spoofing commands and run the sniffer all automatically. And perfect, as you can see, everything is running as expected with no errors. If you run this and you get an error, just do exit and run BetterCap again. Next, we want to run the caplet, the HSTS hijack caplet, exactly as shown in the previous lecture. All we have to do is type HS tab, it'll autocomplete for us, and hit enter to run it. Again, as you can see, no errors, so everything is working as expected. Let's go to the target machine and see how this is going to work. So I have my Windows machine right here. This is Chrome, the latest version in April 2019. And before I do anything, like I said, it's a good idea to always just remove the browsing data. And before I actually load any websites, it is very important to understand that even with everything that we're doing right now, if you try to go to Facebook and type .com at the end here, it will not work. What we're doing right now will not work because Chrome right here has a list that is stored on this computer that says do not load facebook.com unless it is loaded over HTTPS. So if you type Facebook right here like this, it will not work. The only way we can do this is if the user first goes to a search engine, for example, google.ie for Ireland. And then in Google, as you can see, Google doesn't use HSTS. So we bypass this using the normal HTTPS bypass. And then if the user in here searches for their target website, for example, Facebook, then our script is going to run in the background and it's going to replace all links in this page for facebook.com with facebook.corn. So if I actually hover over this, you'll see in the status bar, the website that will be loaded is facebook.corn, not facebook.com. This is fine here. It still says facebook.com, but only in the code of the HTML page, facebook.com got replaced with facebook.corn. So if I click on this link, again, as you can see, we get a normal Facebook page, but if you look here on top, you'll see there is no HTTPS. And if you look at the domain name, you'll see it says .corn, not .com. Again, like I said, you can actually keep this .com and use Facebook with one O, or you can add an extra O. You can be as creative as you want with this. This is just an example that I'm giving you. Now, once we're here, we can log in normally with my username, so zaid@zsecurity.org, and put my password 1234567890. Hit enter, and if we go back, scroll up. Perfect. As you can see, we have the username zaid@zsecurity.org and the password all the way up to 90. Now, like I said, the only way for this to work is if the user gets to Facebook through another website that does not use HSTS. If they go on the URL bar and type facebook.com themselves, we will not be able to do this. That's why this is considered as a partial solution and not a full solution.